Jai Hind Vande Mataram. This is Kunal Mehta from Make Me Scientific. In this video, we are going to learn about the projectile motion. We will be also deriving some of the equations related to the projectile motion. So first of all, you need to understand what the projectile motion is. So the definition says that when you throw any object in the air obliquely, not straight, right? Obliquely means just like this, and then it follows a curved path. We are going to neglect the air resistance, and during this entire journey in the curved path, there is only one force acting on it, that is the weight of the body or the gravitational pull of the earth. And since the force is downwards, and that force is only the net force, and the force creates acceleration in the same direction. So only one force downwards, so only acceleration downwards. Downward means along y-axis. So since the acceleration is along y-axis, there is no component of acceleration along x-axis. So what is going to happen? Acceleration always increases the speed. But since there is no acceleration along x-axis, so there is no increase in the velocity along x-axis. So along the horizontal direction, the velocity always remains constant. So whatever happens, it only happens in y-axis. And the object which you are throwing obliquely is known as the projectile. And the path followed by the projectile is known as trajectory, and its path is parabolic. So before we enter into the equations, you need to understand few of the things related to the projectile motion, that the path, the trajectory is parabolic. We will prove it. The acceleration is completely along the y-axis. Just now I explained that you had a ball, kick the ball and it follows this path. At any given point, the ball experiences a force downwards. This force itself is the net force, and that itself is mg. Only one force. So that means this force is the only one force acting in the downward direction. So acceleration in the downward direction is g, and it will not have any component along x-axis. So I'll just make it 0, because any vector along y-axis does not have x component. Right? So that is what it means. So the x component velocity also remains constant, and at any given point, if we are being asked to find out the velocity, you need to understand that you need to draw the tangent to the curve. So at this point in the direction of the motion, so like this, over here the ball would move down, so tangent like this one. Over here the ball is going up, so the tangential velocity in this direction. Okay, so these are all the important things that we need to know. Now, you need to know one thing, that when the ball is in motion, there are many vector quantities and scalar quantities over here. So say for example, if the ball is over here, then the displacement of the ball from the initial position is given by this vector. So I should be saying that final position to the initial position, this is initial and this is final. So this is the displacement of the ball represented by s. Now it will have two components. One is x. So x is the x component of the displacement, and then another is y. So this is y, correct? And this angle with which we are throwing the projectile is theta, anti-clockwise, measured from x-axis. So this is x-axis, and this is y-axis over here. Another is velocity, and velocity is again going to have two components, one in this direction, another in this direction, and you can call this as Vx, this is Vy. But of course I should say that here when the ball is at maximum height above the ground, I should be telling you that this is the maximum displacement in y direction, or you may also call this as height. At maximum height, the ball will have only velocity in x direction. It will not have any component in y direction. You can understand through the vectors. But when the ball is somewhere over here, its velocity is like this. So its x component is Vx and y component is now downwards. So I should be saying that in half of the journey from the bottom part to the maximum height, that half part, the velocity y component was upwards. And in the next half part, that means in the second part from here till here, from the top part to the bottom part, the velocity y component is downwards. So these are some small things that you need to understand. And all the vectors in the above plus y direction are positive. Like here Vy would be positive. Here Vy would be considered as negative. Of course, acceleration is always in the downward direction. So I should be saying that acceleration ay is minus g, because we are supposed to assign plus and minus also, because we are dealing with vectors. Plus y-axis positive, negative y-axis negative, plus y-axis positive, negative x-axis negative. So these are some basic things. Now, before going ahead to the equation of trajectory, I will split up the entire motion into two parts, correct? So I'm going to assume a very large tube light which is kept at the top, which is throwing light in the downward direction. So consider a tube light at the top which is throwing light in the downward direction. And I'm going to show different positions of the ball at different time. A single ball, when you are kicking this ball, this is position of the ball at time is equal to 0, position of the ball at some other time, this is position of the ball at some another time, and when the ball completes its journey, the ball reaches over here, right? So now when you shine a tube light from the top, you see the shadows. Now shadows of the ball were on x-axis. So I'm going to say that at time is equal to 0, the shadow of the ball is also there itself. But at location number 2, the shadow of the ball is here. At location number 3, the shadow of the ball is here. At location number 4, the shadow of the ball is here. And when the ball reaches at point 5, the shadow reaches over there. So what happens when the ball reaches from time is equal to 0 to say time is equal to t, when it completes its journey, the ball moves along x-axis like this one. Now, in the same way, we also have to place the tube light along the y-axis, and we need to understand the shadow of the ball along y-axis. Here we saw that when the ball was completing its parabolic path, its shadow was moving along x-axis in a linear path. Similar shadow we will obtain by using the tube light like this. Now the tube light is throwing light into the left hand side. So at different locations of the ball, I will show you again. These are the different locations of the same ball. Here time is equal to 0. Here the time is equal to t. So now the shadow will be formed on which axis? Y-axis. And the shadow is always opposite to the light, correct? So now the light falls on this. So the shadow is formed here. In the same way, the shadow of this is formed over here, shadow of this formed over here, and the shadow of time is equal to 0 and time is equal to t are exactly at the origin itself. So now look very patiently. At time is equal to 0, the shadow is on the y-axis here. Now this is the location number 1, location number 2, location number 3, 4 and 5. Now at location number 2, the shadow rises slightly higher up along the y-axis. At point number 3, the shadow is at the highest position along y-axis. I am going to call this as maximum height. But when the ball reaches at location number 4, the shadow drops down. This is 4th location. Again, 5th location, the shadow comes down. So basically the shadow along the y-axis goes up and then down when the entire ball is moving in this direction. So you need to only consider the shadow's motion, and now we will apply these 3 equations of motion. S is equal to ut plus half at square, v is equal to u plus at, and v square minus u square is equal to 2as. We can only use these 3 equations when acceleration is constant, and of course here acceleration is constant along x direction, that is 0, and along y direction, that is g. So I'm going to split up this into 2 parts, x-axis. So wherever vectors are there, assign x and y. So since displacement s is a vector, so I'm going to write down x, u is a initial velocity, so ux, time is simply the scalar, minus half, plus half ax times t square. Because displacement, initial velocity and acceleration are only vectors. Similarly, in terms of y, is equal to uy t plus half ay t square. In the same way, this one is vy is equal to uy plus ay times t, and again vx ux plus ax times t, and the last equation is vy square minus uy square is equal to 2ay sy is basically y. Okay, and again in x direction, vx square minus ux square is equal to 2ax times x. Correct. Now remember, we discussed that the acceleration along x direction is 0 because there is no force along x direction. Weight is in this direction, and ay is equal to minus g. Now one more thing that I would like to highlight over here is the following. When you take u, that is the initial velocity. And what is initial velocity? It is the velocity at time is equal to 0. So I'm going to draw this with a black pen. This was the ball at time is equal to 0, and this is initial velocity u. This is the angle of projection theta along x-axis with anti-clockwise direction. So basically I should say ux is equal to u cos theta, that is x component, and uy is going to be the u sine theta. Very simple. So ux, uy, ux is u cos theta. Simply this is positive. This is going to be the positive in first half and negative in the next half, but we don't have to worry about that, right? So these four things we need to substitute in these equations, right? In these two, and these two equations. So in the next part of the video, we are going to do that.